The most powerful telescope ever launched into space made another successful step on its journey to a point a million miles away from Earth today.
And take a look at this. NASA's James Webb Space Telescope has captured unprecedented pictures of a newly discovered exoplanet.
The signal came as a faint but distinct glimmer, too sharp, too regular, too rhythmic to be anything that nature could easily explain. The James Webb Space Telescope, locked onto Proxima Centauri B during a dedicated observational window, began returning spectroscopic and photometric data that startled the team on the ground. Among the infrared reflections bouncing back from the planet's night side, there appeared a pattern that matched no geological or atmospheric phenomenon ever cataloged. The distribution of light was too structured, concentrated in pockets across the dark hemisphere, and it exhibited a wavelength profile consistent with artificial illumination. The idea that humanity might be looking at the glow of city lights on a planet orbiting our nearest stellar neighbor sent shockwaves through every scientific control room linked to the telescope's feed. Before we start, smash the like and subscribe buttons for more updates. Proxima B had long been a target of speculation. Orbiting within the habitable zone of the red dwarf Proxima Centauri, the planet had intrigued astronomers for years because of its proximity, just over 4 light-years away, and its Earth-like mass. Its tidal locking, though, posed questions about habitability, with one side perpetually bathed in light and the other locked in endless darkness. What the James Webb detected was positioned exactly where the night side met the Terminator line, in sprawling arcs and clusters, each patch of illumination bright enough to be separated from the faint background glow of the planet's reflected starlight. This was not the diffuse shimmer of auroras, nor the glint of ice caps reflecting distant light. This was concentrated and deliberate. The observation was made possible by Webb's advanced infrared sensitivity, which can distinguish even minute variations in heat and light. Artificial illumination, especially in wavelengths akin to those used in human cities, produces a distinct spectral fingerprint, slightly different from the blackbody radiation of natural sources. In the case of Proxima B, the telescope recorded peaks in the spectrum that hinted at specific emission lines, as if the lights were generated by sources designed to optimize visibility in a dark environment. The data suggested that the lights were spread in organized grids and arcs, spanning hundreds of kilometers, hinting at large-scale settlement patterns. From a purely astronomical perspective, the detection was extraordinary. For decades, scientists had debated the feasibility of detecting alien civilizations through indirect signs, from atmospheric pollution to industrial heat signatures. City lights had always been considered a distant possibility, something far beyond our current technological reach, yet here, only 4 light-years away, a planet that had been a subject of cautious optimism was revealing hints of energy use on a scale that paralleled or even exceeded our own. The geometry of the illuminated areas suggested infrastructure, possibly road networks or concentrated hubs of activity. The sheer intensity of the light was remarkable, given that any civilization on Proxima B would likely be using energy sources adapted to their planet's unique conditions. The implications of such a discovery strike at the heart of the search for extraterrestrial intelligence. Light on the night side of a planet is not an accidental phenomenon. It requires intent, technology, and societal organization to produce and sustain. The fact that these lights appeared on the dark hemisphere of Proxima B raised questions about the civilization's adaptation to their world. If the planet is indeed tidally locked, then half of its surface never sees the star's light. A technological society might thrive in that perpetual darkness by building entire habitats illuminated artificially, possibly to protect themselves from the volatile flares of their red dwarf sun. This would mean a way of life fundamentally different from ours, where day and night are not natural cycles, but engineered experiences. Webb's instruments also revealed subtle fluctuations in the brightness of the lights over time. These variations were small but consistent, hinting at activity cycles. Some regions dimmed slightly in what could be interpreted as an energy-saving phase, while others brightened in patterns that might correspond to transportation or seasonal changes in the society's needs. This rhythmic quality distinguished the observation from natural phenomena, which tend to vary chaotically or in line with planetary rotation and orbital dynamics. The synchronization suggested a civilization capable of large-scale coordination. The mere act of detecting such lights is a triumph of engineering and astronomical precision. The James Webb Space Telescope operates in a realm of sensitivity where it can distinguish the faint glow of a planet's atmosphere from the blinding light of its star. The technique used to detect the Proxima B lights involved carefully timed observations when the planet's night side was fully facing the telescope, coupled with long-duration exposures to collect as much light as possible. The team then employed advanced data processing to filter out noise and background interference. What remained was a signal so compelling that the usual cautious language of astrophysics, words like candidate and possible, was strained to its limits. The choice of Proxima B as a target had always been strategic. Its closeness to Earth means that even faint signals are less diluted by distance, and its orbit allows for relatively frequent observation opportunities. For years, scientists had hoped to learn more about its atmosphere, searching for biosignatures like oxygen or methane. The detection of possible artificial lighting, however, bypassed the usual chain of speculation about microbial life and leaped directly to the possibility of an advanced civilization. If the interpretation holds, humanity would be staring at an engineered phenomenon from another world. The patterns of illumination also invite speculation about the nature of the society that might have built them. The most brightly lit areas appear to be concentrated along the edge of the Terminator, the boundary between eternal night and the dim glow of eternal day. This region might offer a balance: stable temperatures, access to both starlight and darkness, and potentially a more temperate climate. If a civilization emerged there, it might have spread outward into the darker regions, bringing with it the infrastructure to light and heat entire communities. The lights could be more than just a means of seeing. They might be life-sustaining, providing the necessary warmth and energy in an otherwise frozen half of the planet. The concept of seeing another civilization's lights has a unique emotional impact. It bypasses abstract science and connects directly to the human imagination. Every night when we look down from space at Earth, we see the sprawling networks of our own cities glowing in the darkness, evidence of life, culture, and technological achievement. To think that another world might have its own glowing patterns, visible across interstellar distances, is to glimpse a profound kinship with the cosmos. It suggests that we are not the only ones to shape our environment in ways that defy nature's limits. The light detection also opens a floodgate of scientific questions. What energy sources power these lights? Are they based on something familiar to us, such as electricity, or on a technology entirely beyond our comprehension? Could the civilization be using wavelengths optimized for their biology? Perhaps invisible to human eyes, but still detectable in the infrared range. Webb's data hinted at a spectral profile that might correspond to efficient, long-lived lighting systems, possibly akin to our LEDs, but tuned for the needs of life under a red dwarf star. There is also the question of how long these lights have been shining. Did we happen to catch this civilization at a particular stage of its development? Or have these patterns been in place for centuries or millennia? If the latter, they might be evidence of a remarkably stable society, capable of maintaining large-scale infrastructure over vast spans of time. If newer, they might indicate a civilization in the midst of rapid expansion, its lights spreading across the dark hemisphere like the glow of human cities during our industrial age. Proxima B's proximity also stirs the imagination in a way that more distant exoplanets cannot. At just over 4 light-years away, it sits on our cosmic doorstep. The lights we see now are a snapshot from a little more than 4 years ago, a trivial gap in astronomical terms. This means that if we were somehow able to send a message and receive a reply, the exchange could happen within a human lifetime. The detection of artificial lights transforms Proxima B from a distant curiosity into a neighbor whose presence feels almost tangible. The nature of Proxima Centauri itself adds complexity to the picture. Red dwarfs are known for their volatility, producing powerful stellar flares that can strip away atmospheres or bathe planets in radiation. If a civilization has survived and thrived under such conditions, it must have developed advanced methods of protection. Perhaps underground habitats connected by illuminated surface structures or atmospheric engineering to shield against harmful radiation. The lights could be part of that protective infrastructure, serving purposes far beyond illumination. The discovery also challenges long-standing assumptions in the search for extraterrestrial intelligence. Much of the focus in recent decades has been on detecting radio signals, under the assumption that communication would be the easiest techno-signature to find. Yet here, if confirmed, is a purely visual marker of civilization, one that requires no intent to communicate, only the byproduct of a society going about its daily life. This aligns with the idea that the most detectable signs of alien life may not be deliberate messages, but the unintentional glow of their activities. From a technological standpoint, the detection is a case study in the limits of human ingenuity. The Webb telescope's stability, its ability to hold a target in perfect alignment for hours, and its precision instruments make it the only tool currently capable of such a feat. It represents the culmination of decades of engineering and planning, all aimed at answering questions that reach to the core of human curiosity. The fact that it could detect what might be the light of alien cities is a testament to just how far observational astronomy has advanced. As data continued to stream in, astronomers examined whether any other phenomena could account for the observations. Could volcanic activity produce such patterns? On Earth, active lava fields can glow brightly, but they tend to appear in irregular, transient shapes, not the organized grids seen on Proxima B. Could reflective mineral deposits be scattering light from the planet's star? The spectral signature argued against this, showing consistent emission rather than reflection. The case for artificial illumination grew stronger with every round of analysis. The brightness distribution also hinted at cultural or logistical differences from human cities. Some of the illuminated areas were vast and continuous, spanning regions far larger than even our largest metropolitan zones. Others were isolated dots, perhaps outposts or small settlements deep in the perpetual night. The variation suggested a planet-spanning network of habitation, with regions connected by whatever transportation or communication systems their civilization employs. It might be a world where travel is routine, and where darkness is not an obstacle, but a constant feature of life. These lights, if truly artificial, are more than a sign of life. They are a sign of community, of individuals gathered together under shared structures and systems. They imply agriculture or resource extraction to support those populations, political or social organization to manage them, and a technological base capable of generating sustained power. The fact that we can see this from across space underscores the scale of their achievement. To be visible to us, their lights must compete with the glare of their star and the vast darkness of interstellar space. The realization that we may be looking at another world's nightscape is both exhilarating and humbling. It hints at the possibility that technological civilizations may not be rare accidents, but natural outcomes under the right conditions. Proxima B's status as a rocky planet in the habitable zone was already encouraging. The addition of potential techno-signatures makes it an unparalleled subject of study. Every photon captured from that distant world is now being scrutinized, each data point weighed against the possibility that it represents not just geology and climate, but the deliberate shaping of an environment by intelligent hands. If the interpretation holds, the lights of Proxima B will mark a turning point in our understanding of the cosmos. They will stand as the first time humanity has observed not just life, but civilization on another world. It will be a moment that collapses the distance between us and the stars, transforming abstract curiosity into a tangible connection. The image of those lights, scattered across a world bathed in perpetual darkness, will become one of the most iconic in human history. A reminder that in the vastness of space, we may not be alone. The scale of the illumination on Proxima B continues to baffle those poring over the raw and processed data. While the initial observations focused on the simple fact that the night side was aglow, the subsequent deeper analysis began to reveal structural intricacies hidden within that glow. High-resolution composite imaging, stitched together from multiple passes of the James Webb Space Telescope, showed that the lights were not evenly distributed, but instead formed complex patterns, clusters, lattices, and even apparent radial arrangements that hinted at a level of urban and architectural planning far beyond what natural processes could imitate. In some sectors, the brightness seemed to radiate outward from a central hub. as if some towering or centralized structure was broadcasting its illumination over great distances. In others, smaller light clusters aligned along what could be pathways, supply lines, or travel corridors that linked one hub to another. As the telescope's infrared spectrometers continued to capture the glow, scientists noticed subtle gradations in the intensity and color temperature of the light. Some regions shone with a warm hue, reminiscent of the golden glow from sodium vapor lamps on Earth, while others were cooler, sharper, almost bluish-white, suggestive of more advanced, energy-efficient technology. The variation raised intriguing questions. Were these differences the result of aesthetic choices by the civilization, much like the way human cities adopt distinctive lighting styles? Or were they functional, perhaps tuned to different environmental or biological requirements? The diversity of spectral profiles indicated that this civilization, if real, was not monolithic in its infrastructure. It was varied, possibly composed of different cultures, regions, or technological traditions coexisting across the planet's dark hemisphere. Further scrutiny revealed something even more compelling. Some of the illuminated zones appeared to shimmer in a controlled, periodic manner, as if parts of the infrastructure were dynamic rather than static. This could suggest that the lighting systems were adaptive, brightening and dimming according to need, time, or activity levels. It might be a sign of advanced energy management, a conscious effort to avoid waste while ensuring that all inhabited areas remained functional. From our perspective, these fluctuations appeared as rhythmic pulses in the infrared data, repeating in cycles too complex to be caused by any purely natural oscillation. The distribution of these luminous clusters also gave hints about the planetary geography. Even though the night side was hidden from direct optical view, the arrangement of lights traced patterns that followed what could be coastlines, river valleys, or geological formations. In several areas, the glow formed crescents and arcs suggestive of settlements hugging the edges of possible seas or lakes. If this interpretation was accurate, it implied that Proxima B's dark hemisphere still supported large bodies of liquid, likely water, protected from freezing by either geothermal activity, artificial climate regulation, or both. The presence of illuminated settlements along these bodies would make sense for a civilization dependent on stable water sources, agriculture, and transport. In one particularly striking zone near the equatorial terminator, the light intensity was so concentrated that it appeared as a luminous spine stretching for hundreds of kilometers. This could be an immense urban corridor, perhaps a megacity spanning multiple regions, or it might be a vast complex of industrial, scientific, or cultural significance. The sheer brightness of this structure suggested a facility or urban center operating at immense power levels, possibly rivaling the output of entire human nations. If this was indeed the case, it spoke to a civilization not only advanced enough to master planetary-scale energy distribution, but also confident enough to illuminate vast swaths of its surface in the eternal night. Beyond the purely physical details, the discovery provoked deep reflection on the cultural dimensions of such a civilization. A species that has built its existence in perpetual darkness would have evolved or engineered an entirely different relationship with light. On Earth, light is an ancient constant, dictating circadian rhythms, seasonal changes, and biological patterns. For Proxima B's dark side inhabitants, artificial light might be as fundamental to survival as air or water, woven into every aspect of their environment and culture. They might navigate not by the changing position of a sun, but by fixed constellations of engineered brilliance, each settlement a beacon in the blackness. Such a society could have myths, rituals, and histories tied not to natural dawn and dusk, but to the maintenance and evolution of their illuminated world. The James Webb data also hinted at something that stirred the imaginations of both scientists and the public. Occasional flashes, far brighter than the surrounding constant glow, appearing in certain concentrated areas. These transient bursts could be anything from industrial processes to energy discharges, or perhaps even transportation events involving immense power output. Their regularity was inconsistent. They occurred unpredictably during the observation period, yet their profiles did not match those of meteors, lightning, or volcanic eruptions. It was as though somewhere on that distant world, activities were unfolding that we could only begin to guess at, each burst a whisper of some unknown technology or event. Another revelation came from analyzing how the lights interacted with the planet's thin atmosphere. The spectral readings suggested faint but detectable scattering effects, as if the light were diffused through particulate matter or controlled atmospheric layers. This scattering could be a byproduct of environmental engineering, perhaps a protective dome-like shield over certain settlements designed to filter harmful stellar radiation from Proxima Centauri's flares. Such a structure would refract and diffuse light in distinctive ways, and Webb's sensitive instruments seem to catch the fingerprints of just such an effect in a few concentrated regions. The complexity of the lighting networks pointed toward extensive energy infrastructure. On Earth, our cities rely on a vast web of power plants, transmission lines, and distribution systems. On Proxima B's dark side, sustaining such brilliance across so many locations would require a stable and abundant energy source. Scientists speculated on possible candidates: nuclear fusion, geothermal tapping from the planet's core, or even stellar energy harvested on the bright side and transmitted to the dark hemisphere via orbital satellites or subterranean conduits. The possibility that they might have mastered some as yet unimaginable power source lingered over every conversation about the data. The proximity of Proxima B to its parent star also meant that any civilization there would face unique engineering challenges. Red dwarfs are notorious for their powerful, unpredictable flares. If the night-side civilization exists, it may be deliberately positioned away from direct stellar exposure to mitigate these dangers. This could mean that the lighting systems are not just for visibility, but also integral to life support, maintaining habitable temperatures and driving biological cycles. The very existence of such a network could imply a planetary society that has adapted to, or even fully embraced, the harsh conditions of a tidally locked world. As Webb continued to collect data over successive observation cycles, another subtle feature emerged: seasonal variation, or rather, a planetary equivalent. While Proxima B's orbital parameters and tidal locking would eliminate conventional seasons, there could still be cyclical environmental shifts due to orbital eccentricity or atmospheric dynamics. The lights in some regions seem to grow more intense during certain parts of its orbit, hinting at increased activity or energy demand. This might correspond to environmental stresses, agricultural cycles, or cultural events. Much as human societies have periods of heightened activity during harvests, holidays, or festivals. It was the patterns themselves, however, that most fascinated the researchers. The possibility that some of these illuminated designs could hold symbolic meaning became a subject of spirited debate. Some arrangements were so geometrically precise, forming perfect hexagons, concentric circles, or linear arrays stretching for dozens of kilometers, that they seemed unlikely to be purely functional. Were these designs aesthetic expressions, visible only from high altitudes or space? If so, they could serve as cultural markers, perhaps even messages to any who might be watching from afar. The thought that a civilization might decorate its planetary face for the cosmos to see was both poetic and unsettling. The nature of these lights also raised questions about their visibility to the inhabitants themselves. If the atmosphere on the night side was thin or clear, the lights would dominate the horizon in every direction, turning the darkness into a perpetual twilight under artificial stars. On Earth, cities often glow so brightly that they obscure the natural night sky. On Proxima B's dark side, the balance between their artificial constellations and the true stars might be an ever-present feature of life. The inhabitants, if they exist, might grow up recognizing not Orion or the Pleiades, but the sprawling arc of their own city's glow as a defining landmark in the heavens. The engineering implications are staggering. Maintaining thousands of square kilometers of illumination in such a hostile environment suggests not only technical skill, but societal stability. On Earth, large-scale infrastructure projects require coordination, governance, and long-term vision. A civilization capable of building and sustaining a planetary nightscape must have mastered political and social systems capable of supporting cooperative ventures on an epic scale. This stability could be an indicator that the species has survived its technological adolescence without destroying itself, an encouraging sign for those who ponder the Fermi paradox and wonder why the galaxy seems so quiet. There is also the intriguing possibility that the civilization might be older than humanity. If Proxima B formed billions of years before Earth, life there could have had a head start of immense proportions. The lights we see might be the product of a society with an unbroken technological lineage stretching back tens of thousands or even millions of years. Such a timescale would allow for architectural and technological refinement far beyond anything we can presently conceive. They might have evolved past the messy trial and error phase of infrastructure and reached a stage where every component of their environment is the product of deep, deliberate design. The observation also reframes our understanding of habitability. Until now, much of exoplanet research has focused on worlds with Earth-like conditions, planets with day-night cycles, moderate climates, and similar atmospheric compositions. The lights on Proxima B suggest that intelligent life might thrive in conditions vastly different from our own, using technology to overcome what we would see as insurmountable obstacles. The perpetual darkness of a tidally locked hemisphere is no longer a barrier but a canvas, an environment to be mastered and illuminated according to the needs and aesthetics of its inhabitants. From a practical standpoint, the detection presents a roadmap for future exploration. Knowing that the night side glows with artificial light means that any future probes, telescopes, or even interstellar missions can focus on these illuminated regions as primary targets for study. Instruments could be tuned specifically to the wavelengths most prominent in the current observations, increasing the chances of extracting further detail about the composition, energy sources, and possibly even the surface structures themselves. If humanity ever develops the capability to send a fast probe to Proxima B, these lights would be the obvious beacons to aim for. One cannot overlook the potential technological gulf between our civilizations. The fact that we are detecting their lights at all suggests a civilization operating on scales visible across interstellar space, yet they may not even be aware that we are observing them. Our own Earth, from 4 light-years away, would reveal its cities only faintly, requiring extremely sensitive instruments to discern. If their lights are more conspicuous than ours would be under similar observation, it could mean they are either vastly more energy-intensive or deliberately broadcasting their presence. The latter possibility, intentional visibility, carries profound implications, hinting at a culture open to contact or communication with others in the galaxy. As Webb's mission continues, refinements in data analysis are expected to peel back even more layers of detail. The initial findings have already prompted requests for follow-up observations using Earth-based arrays to monitor Proxima B's radio and microwave emissions in parallel. If any correlation emerges between these emissions and the observed light fluctuations, it would strengthen the case for a technological civilization. Such a dual detection, visual technosignatures, and electromagnetic activity would represent the most compelling evidence yet of intelligent life beyond Earth. Even without direct contact, the mere awareness of those lights changes the human perspective. They serve as a reminder that the universe is not static and empty, but dynamic and potentially inhabited in ways that defy our assumptions. In the darkness between the stars, there may be countless other worlds glowing softly in the night, each with its own story, its own struggles and triumphs, its own history written not in words, but in the patterns of light spilling out across its surface. And Proxima B's story, as glimpsed through the James Webb Space Telescope, is only beginning to unfold. Every observation adds a brushstroke to the picture, revealing a civilization that may have mastered the art of thriving where light from its star never falls. The dark side of that world is not a wasteland, but a tapestry of luminescence, each point of brightness a possible home, a workplace, a meeting place, a testament to the creativity and resilience of beings who, though unknown to us, have left their mark upon their world in a way we can see from across the void. In those distant lights lies the promise that we are part of a larger, living galaxy, one in which the spark of civilization is not confined to a single pale blue dot, but shines wherever life dares to tame the dark. The illumination on Proxima B's night side is not uniform even at the smallest detectable scales, and this irregularity has become a focus for those modeling the planet's surface environment. In some regions, light intensity fades gradually toward the outskirts of settlements, suggesting suburban or rural zones, while in others it drops sharply, as if the civilization has carved out strict boundaries between inhabited and uninhabited terrain. Such abrupt transitions could mark environmental preserves, dangerous geological areas, or resource extraction sites intentionally kept dark. The interplay between bright and unlit zones hints at deliberate land management, a sign of planning that may be centuries deep in tradition. A particularly tantalizing detail emerged when analysts applied temporal mapping to the collected data. By layering multiple passes over the same areas, subtle movement in the light patterns became visible. These were not the sweeping changes of weather systems, but localized shifts. A light source brightening in one location while dimming in another, small networks expanding slightly over the course of weeks, or isolated points blinking into existence where none had been before. This suggests growth and adaptation, evidence that the civilization is not static, but actively reshaping its environment in real time. Such changes could represent new construction, mobile facilities, or even temporary events that require large-scale lighting. The faint halo around some brightly lit sectors also drew attention. In the infrared, this glow extended beyond the core light sources, diffusing into the surrounding darkness. This could be atmospheric scatter, but its consistency in certain regions raised the possibility of deliberate illumination zones designed to light surrounding landscapes for navigation, agriculture, or security. These halos might serve as visual markers visible for vast distances, much like lighthouses across seas of shadow. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on city lights on Proxima B? What do you expect? We want to hear from you. Thank you for watching and see you next time.